earlier people used to, before starting the car, they used to kick their tires, every tire. So they used to take a round around the cars, okay, to inspect the tires. You know, you sit in the chair, the system will tell you that what is the condition of your tire, your fuel, oil status, your radiator status. So the things are improving. Now we have a digital twins. Now the concept of digital twin is that whatever the physical machine that is available, we have a physical twin. I mean, a physical machine is there, we have a digital twin. Digital twins means that as machine is working, it is taking some data, it is doing something, it is making some product. In the same way, in the cyber world, its digital twin is existing. That can keep monitor that how many units it has produced, what it has done, okay? It means it's all about controlling software. You do not have to actually physically go there and count the number of items produced. The machine, the digital twin is telling you on your laptops and desktop that how many parts it has produced, how many product it has produced, what is the efficiency rate, what is the health of our machine is, some repair or maintenance is required. That can also be forecasted early. Okay, and on the longer run, you have some, let's say 10 units doing the same work. The system can monitor that unit number 4 and 5 will go out of order very soon. They require maintenance. So this is what integration of IoT, the physical machine, IoT, cloud, AI. So three things are working in a unison to give you a digital twin. So a virtual digital model acts as an analytical counterpart that processes the data to simulate and predict behaviors, consumes incoming data, streams to maintain an accurate and synchronized state. Okay, you are manufacturing a small part. So earlier, you know, if you go to Kanpur and other industrialized towns, this plastic glass, if you go to purchase it from retailer, it is available that 50 rupees per piece for a packet, and a packet has 20 pieces or 25 pieces. So hardly the cost is around 1 rupees. Clear? But the wholesaler is purchasing, yes.
Sir, digital twin is only for monitoring or controlling also?
See, the thing is, if you can monitor, you can control.
Like we can give command over there.
Yeah, you can command, you can shut down. I'll give you an example. You remember the era of CDs, Moser Bear? You know, CDs. Okay? Still, if you visit some industry in Surat, you know, the cloth is being produced and it is in lengths, and it undergoes with many motors, with many processes. If one motor is out of order, the next motor is low on battery. So if one motor is out of order, the other motor will pull that cloth and entire, yarn, your entire cloth sheet will waste. And to actually start and stop that entire line of length of cloth production, okay, you need a very, very good electrical engineers, good softwares, which will stop every 400 or 500 motors, and each motor with certain gears is moving with certain velocity. Okay, because let's say in this part your cloth needs to spend 15 minutes in a machine, 5 minutes in a machine, and at some other speed, some other machine, the same which is being processing the cloth, the cloth needs to still stand at 3 seconds. So there is a differential of 2 seconds. So that is being maintained. That is why if you have a picture of old movies, so you see that cloth is moving up, coming down. So this is all being controlled with the time delay. It's a time delay. Clear? So controlling is also there, and your monitoring is also there. Clear? So that is how it is being served. But earlier we had very, limited machines that can actually be controlled through software. Now every machine has its own digital twin. You buy a physical machine that will do work for you, and you have a counter pair software, through which software you can control the machine. Okay, no need to do so. Tata Power company, Tata Power. So they are supplying, it's into distribution mostly. They have, I was working in BBD, so I had made a software for them, which is actually taking latitude and longitude, and through latitude and longitude it is calculating the sunset time and sunrise time, and through sunset and sunrise they control the on off of their power. Okay, our simple UP state electricity board, their tube lights is on still in the day. You must have seen earlier. Now you hardly see that light is on in the day. Now how it is possible? It is because the machines have improved, not the UP Power Corporation has improved. They are operating on same thing. What are they doing? They are started putting the intelligence systems. Clear? And through one switch, at some engineer at Tata Power can shut down the entire electricity of the town or a city or any area. They can control the transformer. Each transformer installed by Tata Power communicates to Tata Power centers that what is my temperature, what is the input load, what is the output, how much current has been drawn, I am under load or I am overload. And that is why the UP states electricity transformers, they go out of order in summers. Transformer jal gaya. Clear? But if that same situation, Tata Power's transformer is there, it informs the center, shut me down or else I'll go out of order. So they shut it down. Once the temperature, there is a cooling oil inside the transformer, temperature is brought down, they again start the power. Okay? So that is how things do. Okay? So smart sensors is very important, because sensors collect data from the environment and they send it to, next step is that data is sent to central systems. Okay? And then real-time monitoring of collected data happens. So this is the software. Okay? Now this sensor is actually collecting data from the machine. Once it comes to this software, you can do real-time monitoring and you can do the controls. Clear? Now we have interoperability. That means machines communicate with each other. Means two machines of same kind can communicate. And that happens because we have HTTP, MQTT, okay, and TCP/IP protocols. Now the industry standard is MQTT. It is MQTT. Okay. So you have heard about Mosquito. If you can install that Mosquito software, so you can put it in your devices, and that device can control. They can send that data to the central server, and from the central server you can actually monitor the device. So you can make any device to communicate. And but you can also do communication with HTTP and TCP/IP. But for that, what will happen is that you have to actually write proprietary softwares at device level. So which is very hectic. Okay. With the help of MQTT, you can install it, and it roughly takes care of every devices. Now we have applications, IoT based application, industrial automation, smart cities. These are these are actually a type of applications. And we have machine communication and technologies. The technologies which are supporting this: wireless, wired and Bluetooth. This is how the machines communicate with each other. Okay? That means two Volvo bus or Mercedes Benz bus can say hello among themselves. Okay? They can communicate, they can pass the data. Clear? Sorry. Yeah. Now, with with this help of communication, we can have decentralization. Decentralization means no single fellow, no single person, no single maintenance hub, workshop can actually take major decisions about maintaining a device. Okay, suppose a bus has been broken down, let's say in a very small city, and it is en route with this UP Roadways Corporation. A small mechanic which is not fully trained, okay, can do repairs because somebody at remote site will be helping, assisting him. Clear? This assistance is being given to them. Clear? If you buy a BMW car and if it breaks down, every BMW car is connected to BMW's own private satellite communication network. So they will provide the support on the site, and this all happens because of one thing, communication, because they can communicate. So we can have a decentralized system which is have distributed control, shared responsibility and collaborative management. Okay, and this is all happening through network connections, interconnected system, or with the help of communication channels. The independent systems means multiple entries, independent operations, and autonomous decisions can lead to self-governance, no central authority. And this is what decentralization helps us. Okay, clear? So that means, to more relevant example, a doctor in a small CHC center, okay, can help a patient if he is connected to some expert at major city. Okay, he can pass on the symptoms of the patient to that expert. The expert will say that no, the patient is undergoing a heart attack. You do this, you do this. So at least the life of the patient can be saved. So that means there is no central agency. Everything is decentralized. You can take small steps which lead to major impact. Okay, which leads to the major impact on your system overall. Now, and what will happen if everything is decentralized? Instant data processing. Next step is what? If you have everything decentralized, we have instant data processing. Now real-time analysis is there. Immediate insight is being provided because real-time data is collected. So we have speed. We have a speed, precise interpretation, and informed decision leads to accuracy. So, and how the efficiency improves because instant data processing is there. So your overall system is very efficient. Clear? Now, this helps in resource optimization, reduces the cost. Clear? Got it? Those who know the AKTU system, so earlier they used to send the question paper to post office. No, earlier they used to send the question paper before the start of the examination to all the colleges. Once it is being reached to all the colleges in UP, day one maths paper first will happen in first shift. Now they started using post office for that service because of communication. Now they mail to every examination controller of college, so everything is decentralized. So what happens? Overall efficiency is increased. Okay, and speed is there. Now if there is some problem in the question paper, you can communicate onto that channel and the solution can come. So we have overall speed, efficiency, okay, and accuracy. So similarly, if machines have been connected on real-time data, insight is there, you have precise interpretation of data, so resource optimization and cost reduction happens. Now, manufacturing as a service. This is a model that is being used in China. You have heard about Alibaba? Most of you have. And IndiaMart in India, what they do? You place certain amount of order. You want to manufacture this remote. What problem with this remote is it can fall off. And if it falls off regularly, it can break. Now once it is broken, what will happen? You need to buy one. So you can have a company which gives an order to some company in China, okay, which is manufacturing remotes for everybody. But since you have placed an order of minimum order of let's say 50,000, 5,000 remotes, you will get that reward, and you can sell them to the colleges that this is a spare one, keep it with yourself. If this breaks up, use the other one. Clear? So that means now manufacturing is a service. You want to launch your own paracetamol in the market. You go to Chandigarh, you go to Haridwar, place the required amount of order of paracetamol tablets with your own brand name. Let's say Amit paracetamol. They will manufacture it for you. They will use your own license. All the certification they will use.